All right, we are going to take a short little detour from the Go Math book and talk about a special set of numbers that we should have memorized. Just like you would have your doubles with addition, like 1 plus 1 is 2, 2 plus 2 is 4, 3 plus 3 is 6, and so on. We're also going to be looking at this unique set of numbers that we call perfect squares. And this is the 1 times 1, 2 times 2, 3 times 3, 4 times 4, and so on, all the way to 10. This set of numbers actually divides the multiplication table in half. So if we look right in here, for example, and I can go ahead and get zoomed up here. If we look right here, as this line is going through, all right, so we have this line that comes through right here. Right on this side of the line, we've got 4 times 3 is equal to 12, and then 3 times 4 is equal to 12. All right. If we expand this line out, all right, here is 6 times 3, and here is 3 times 6. So what the perfect squares will do for us, right, is to divide the multiplication table in half so that what looks like 24 problems that you have to memorize actually just turns into 12. So let's get right to it and talk about this concept of perfect squares. So here is our goal. I can find the product of a number that creates a perfect square. Product being the answer to a multiplication problem, and the number that we are going to multiply. And it's going to be a very unique relationship. All right, we are multiplying the same number. Okay, so a 1 by 1, or 1 times 1, gives us 1. Okay, 2 up, 2 across, gives us 4. 3 by 3. And I think that right now, hopefully what you can see is that the reason that we call them a perfect square is because it makes a square. All right. 4 times 4, that's 16. 5 times 5 is 25. 6 times 6, 36. And again, we have a square that is created by those tiles. Okay. What do we know about a square? Well, a square must have not only right angles in every one, but each of the sides, and we'll use 4 right here, each of the sides must be the same. A square has equal sides. Perfect square numbers have the same amount. Here's 7 going up and down, 7 going across. There's 7 right here, and 7 right here to give us 49. 8 gives us 64. 9 gives us 81. And finally, the big one, 10 times 10, gives us 100. Now, as with anything with math, there's always patterns that can be seen. And the perfect squares are no different. And neat little thing here that we can look at least for the first 9. So we're going to not worry about 10 times 10 right now, but we're going to start right here in the middle. 5 times 5 is 25. Okay, it's in that middle section of these perfect squares. And then we have some really neat things that we can see here. The first one, all right, if we look at 4 times 4 and 6 times 6, each of those numbers ends in a 6. All right, so that was something that was kind of neat as you look at patterns. But then we can go even one more. Let's take a look right here. at 3 times 3, 7 times 7. Each of those numbers ends with a 9. And now the pattern becomes even more obvious. All right, we have got right here a 4 and a 4. And then finally, right here, we'll go with orange on this one. We've got 1 and 81. So this is a pattern that just demonstrates here in the first 9. All right, there's some other patterns as you get into the bigger numbers, but these are really the ones that we need to really be familiar with. Okay, so why would we use something like this? Well, in your some of the higher level math classes, we'll talk about squares and square roots and things like that. I'm going to give you just a sneak little peek preview. Let's say that I have let's say that I have 50 tiles, 50 like ceramic tiles that someone has given me. Maybe that's a leftover construction project and they're like, hey, do you need some of these tiles? And I'm like, perfect. You know what? I was hoping to remodel my bathroom. But my bathroom is squared. All right? So I have this square bathroom and I need to get get the right amount of tiles. So what I need to do is to find out, the dimensions of the bathroom that could accommodate 50 tiles. All right, so I need a number that is the same, and these numbers here are the same. So I need a number that is the same multiplied together that's going to get me as close to 50 as possible without going over. And that number is 7. All right, so I could make a room, or an addition to a room, it would be a 7 by 7, which would mean I would be using 49 tiles. All right, so that would be one explanation of how you would use something like that. Okay, now much later on, but I will go ahead and show you this. We talk about a thing called exponents. All right, so if I had 7 to the second power, and again, this is not going to be on any third grade test, but I'm just kind of showing you ahead of time. Okay, what this means is this is the number that's going to be multiplied, and the exponent tells us how many times that number is going to be multiplied. All right, so that would be 7 to the second power, which we nickname or give a shortened name. We would say 7 squared. And that is how we come up with the name for these numbers right here, the perfect squares. The perfect squares are created by saying that they have an exponent of 2 and that we're going to square that number. So the next part of your memorization of multiplication facts is just to simply sit down and memorize these numbers. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. We spend a lot of time memorizing perhaps cheat codes for games, or we memorize starting lineups for your favorite hockey team or baseball team. These are just a set of numbers that you need to memorize. The beauty of this is you've already have some of these committed to memory. Okay? 1 times 1. You know that because that is the property of 1. Any number times itself is equal to 1. All right, you know this one. 10 times 10 is 100. So you already knew that one. You already knew 2 times 2 is 4. This one's a unique one because not only is 2 times 2 4, but 2 plus 2 is 4. You already know this one. 5 times 5 is 25. And you should know this one. 9 times 9 is 81 because we have some unique things that we can do with multiplying on our fingers and using that and knowing that the number is going to be 1 less than what we multiplied. So with this right here, that means you only have 1, 2, 3, 4, 5 additional ones to memorize. All right. So just a quick lesson there. Make sure that these are memorized. This is, like I said, a very special set of numbers that will help you out as you get into higher level math. And they do have a name, and they are called the perfect squares or the doubling multiplication numbers.